Hey guys, for this class, I want to talk about fuzzy logic and fuzzy sequence clustering with you guys. So what is fuzzy logic? The name is pretty interesting. So here comes with an example, fuzzy logic example. Although for computer scientists, we see things in 0 and 1, in reality or in the world, many things are not true or false. For example, the temperature. Everybody have their comfort zone of the temperature. During the winter, I do see someone wear short pants, short t-shirts in a temperature of like 40 Fahrenheit. And to me, I need to wear a pretty big jacket. So ask everybody this question. What is the temperature? Do you feel comfortable? What's the temperature you feel hot or cold? Obviously, everyone will have a different value. For example, I feel the comfortable temperatures to me are 60 to 80, which is a pretty small zone compared with many other people. As long as it's hotter than 95 degree, I feel it's hot, and below 50 is cold to me. Obviously, this is going to be very different from people to people. Everyone have different feelings. Everyone have different comfort zone. Some of them are pretty narrow. Some of them are like huge gap between comfortable. So think about this. When a company is trying to design something in this kind of perspective, how can they fit almost everybody's feelings or everybody's subjective uh, things? It's pretty difficult. So in that case, in computer science, instead of 0 and 1, we want to see things a little bit fuzzy. So there are two assumptions that are essential for the use of formal set theory. So this is like a regular computer science topic. For any element in a set belonging to some universe, the element is either a member of a set, else it is a member of the complement of that set. The second thing is an element cannot belong to both sets and also be its complement. So you can only choose one, which in our k-means clustering, we try to calculate the distance for every single node, and the node belongs to its closest cluster. What if the next closest cluster is actually pretty similar? Maybe just a little bit less goes to the first cluster and it doesn't belong to the second cluster. So in this case, we want to see something differently. So while we try to reasoning with fuzzy set, both these assumptions are violated in Dr. Latif Zadah's fuzzy set theory. So for Zadah's main contention is that although probability theory is appropriate for measuring randomness of the information, it is inappropriate for measuring the meaning of the information. In other words, he wants to use the real world meanings or real world languages to describe the things that he wants to capture. So that process probability theory as a measure of vagueness, just like probability theory measures randomness. It's a little bit interesting. So before I move on, I want to talk with you guys about Dr. Latif Zadah. He was born in 1921. Unfortunately, he passed away in 2017. I personally actually meet Dr. Latif Zadah in person. There was while I was in Georgia State University, and we tried to hold a conference in data mining. Actually, he was invited as a keynote speaker, and I have the pleasure to pick him up in the airport from Atlanta airport, and we take a taxi from airport all the way back to downtown Atlanta Of course, we have some discussions, and he is such a wonderful person. He's the kind of person you want to talk with him all the time. And although he's super famous, he's just like a friend. And we had a very nice conversations during the taxi ride. And when he checked in the hotel, he's just very, very gentleman. Um, in 1965, he proposed the fuzzy set, and that actually changes a lot of things that we think in mathematically as well as in computer science. So the boundary, the most important thing is this one. The boundaries of a set are soft, not crisp. So if one element need to belong into two clusters or more, just let it be. And this creates a very big change in computer science theory, especially in my perspective. In data mining wise, clustering is actually a major change in his fuzzy theory. And that's why we have a major clustering algorithm we want to discuss, which is called fuzzy-seamless clustering in this topic. But of course, I need to let you guys know more about the fuzzy theory. So let's talk about fuzzy theory first in this video. And in our next video, we will talk about fuzzy-seamless clustering in depth. So reasoning with fuzzy sets. The notion of fuzzy set can be described as the following. Let S be a set and as a member of that set, a fuzzy subset f of S is defined by a membership function. So you want to have a membership function to calculate this item and then to measure the degree to which S belonging to the set. And so everything has a degree. So this one may be belonging to this cluster for 55%. And while the other one has another 40% that it belongs to the other cluster, and maybe another 5% belonging to a third cluster. So everything is describing by a membership. So this figure shows you another example of that. So I want you guys to take a look at this carefully. This one is talking about the height. So when people are asking what height do you think is tall? For NBA players, they are probably all on this side, but for regular people, as long as you are as high as 6 inches, it's actually pretty tall already. So you can see that there are some overlapping areas in terms of the concept, especially if you don't consider men and women, which in other words, if we put all humankinds all here together, for a woman in this height, it's actually considered very tall already. So there are some degrees of overlappings, and that is the kind of the concept that fuzzy theory wants to capture. There are a lot of different things using fuzzy logic in engineering perspective, such as washer and dryer machines in the vehicles, in what's that called? Air Okay, so many things are actually using the ideas of the fuzzy logic. So how is it really being implemented? Basically, it consists of 3 steps. First one is that you need to understand the human language perspectives. So what the first thing is what we talk about the linguistic variables, such as hot, cold, comfortable, fast, tall, short, those kind of things. So you need to have a target first. And then you need to use what you think as the linguistic variable to map into the output that you want it to work. So basically, for example, the fans, the electronic fans, if it is cold, don't open up the fans. If it is medium, which is comfortable, then you can turn on the fans a little bit. If it's hot or extremely hot, then you want it to run for the full speed. By this idea, so you see the hot, comfortable, that is the linguistic variables, which is considered as our input, And then we try to map that to the output to the targets that we are looking at. And finally, we have one important step called defalsification. So let's take a look at this example a little bit deeper. So if we want to design a fuzzy controller for air conditioner, and first of all, we need to design I/O, input and output. For this case, we have temperature as the input and the motor speed of the air conditioner as the output. While we try to do that, we need to gather a lot of information from the human for the very first step. So it's never be one person's job. If you want to design some air conditioner that works for everyone, you need to gather as much information as possible. So do a survey, look over 100 persons, try to understand what is hot, what is comfortable for everyone. And then once we gather those things, we try to divide the temperature, for example, into the 5 categories: cold, cool, just right, warm, and hot. And these are the data that needs to come from the survey from the people. And then we will need to design corresponding 5 stages. Since we have 5 stages for the input, we need to also have 5 stages of the output for controlling the machines that we have. And therefore, take a look at this one. While we look into the temperatures for the just right, people are enjoying from 60 to 70 degrees. Unlike me, mine is going from 60 to 80. So everyone has different values over here. We need to summarize, we need to analyze all the results and then create a picture looks like this. And while we do so, we also generate the motor speed according to those 5 different stages. And then we try to map. If it is warm, then we want to use this speed, the fast speed of the fan. So those are the mappings that we can generate. While we have all the things that are mapped, now we created a fuzzy system that can take input and then can generate the output. So that is what we would do at that stage 1 and 2. So in step number 3, which is defalsification, this is the most important part. So once we have the whole picture, now saying the current temperature is 63 degrees, then this 63 degrees will map into 2 different kinds of comfort zones. One is for just right, the other one is for cool. And then we can actually draw the space calculating the percentage of the belonging. So 63 degrees in this defalsification step is indicating 80% consider it as just right, and 15% consider it as cool. So the motor speed can be calculated based on 2 different levels of the belongingness and make the best proper output to turn the motors on. And that is the idea of the fuzzy theory. More importantly, you want to see that for 1 temperature degree, it's not just right. It's 80% just right. At the same time, it belongs to another category. So one thing can belong into 2 or more categories. That is the idea that will lead into the fuzzy C-means clustering. And therefore, in my next video, I want to discuss the fuzzy C-means clustering with you guys in detail. So that would be the video for now.